We will solve the following exercise. The exercise is the number 2.34. As always, first I'm going to solve the exercise and then I'm going to explain what was needed for me to solve it. Alright, so a surveyor measures the location of point A and determines that ROA is equal to 400 plus 800 meters. Right, so ROA is equal to 400 units in the I direction plus 800 units in the J direction. This is in meters. He wants to determine the location of a point B. So that our AB, the magnitude, is equal to 400 meters. And the summatory between those two vectors, which is the magnitude, is equal to 1200 meters. What are the Cartesian coordinates of point B? Now, they are asking for px and py. Now, remember that I always suggest to use the same graphical analysis that the exercise gives to you for you to save time during the test or something like that, although we are going to do it once again right here because I don't like these streamlines or whatever those are. Now, this is looks something like this, and right here we have O or 0, A and B. Now, in the case of A, we have that. Let me draw the Cartesian plane better. Right here we have X, and right here we have Y. Now, according to the vector, I can say that right here I have 400 units, meters in this case, and from here till here I have 800. Let me move this, maybe here. Right here we have 800 units, meters. Alright, as well they are giving me the magnitude of RAB, which is 400, and as well they are giving me this magnitude. Now, this magnitude corresponds to the vector created between our point 0 and B. So right here we have 1200 meters. Now, taking into account this information, I can say that the magnitude of ROA is equal to the square root of 400 squared plus 800 squared, right? Now, this is equal to square root of 400 squared plus 800 squared. Now this is equal to 894.4271. And I'm going to save this within the calculator. So shift storage and A position. Now when I look for the A position, this is equal to the value that I just saved. Alright. Now we have this magnitude. 894 point, what was it? 4271. Now, it is easier if we determine these vector coordinates, right? It is the same thing as doing this, because the exercise is asking for the coordinates of B, right? Now, for the vector RAB, the endpoint is the same one as this one. So that is what we are going to do. Now, for us to determine the coordinates of the resultant vector, as we did, or as we just write the ROA coordinates, we need these two values, correct? Now, for me to have those two values, I need this angle and this angle. For example, this angle I'm going to call it theta, and this angle I'm going to call it alpha. As well, actually I don't think that I need anything else, because once I have this angle and this one, I'm perfectly capable of getting y and x. Now, first we're going to analyze the triangle. So for the triangle, I can analyze it using the cosine's law, because I have the three cathetas. I don't have either of the, actually I don't have none of the angles within the triangle, so I'm perfectly capable of taking just the magnitudes and analyzing the angles. So using the cosine law, I can say that 400 square is equal to 894.4271 square plus 1200 square minus 2 times 894.4271. I'm sorry, this is a mistake, and please do not do this. When I'm writing on paper, I always write a point, but I don't know why in the tablet I always use a comma. But you have to maintain a notation for you to analyze the exercise later, and you for when you want to analyze the exercise later, you could be capable of doing, and you will. Now multiplicate it by 1200 multiplicated by the cosine of the angle theta, right here, this one. Now that means that the angle theta is going to be equal to the cosine to the minus 1 power of, let's see, 400 square minus 894.4271 square minus 1200 square divided by minus 2 times 894.4271 times 1 1200, and that would be all. Now within the calculator I'm going to write down that, so the cosine to the -1 power, always make sure that you are using degrees. Not always, but in this case we need degrees, not radians. So 400 square minus a, remember that I've saved the value of 894.4271 within the a part of the calculator. Squared minus 1200 square divided by -2 times a, I think, correct, times 1200. And I can see right here that theta is equal to 14.3122 degrees. Alright, right there we have it. Now that we have that angle, we are able to find as well alpha. Why is that? Let me see. Right here we have this. Now, for alpha, I'm going to analyze first this other angle, which is, I don't know, I'm going to call it gamma. I'm sorry for the delay, I was thinking what I was doing. This is part of the process. Now, in the case of gamma, I'm perfectly capable of saying that gamma is equal to, for example, the tangent to the -1 power of the opposite cathedus divided by the adjacent cathedus, which is 800 divided by 400. Correct? Now this is the same thing as having tangent to the -1 power of to the -1 power of 8 divided by 4, and this is equal to 63.4349 degrees. Now alpha is going to be equal to gamma minus theta. Now alpha is equal to 14.3122, 49.1227. Sorry, I just mentioned something and I forget it. Alright, now that we have our angle, all we have to do is to use the sine and the cosine of the angle. Now, the cosine of alpha is going to be equal to x divided by 1200, which is the hypotenuse. Now, x is going to be equal to 1200 times the cosine of 49.1227. I'm going to save this and the b apart. Now 1200 times the cosine of b. This is the first coordinate for our B point. Remember, we are getting ROB. This is equal to 785.3287. I direction plus the same thing but using sine. Why is that? Because the sine of alpha is equal to y divided by 1200. So y is equal to 1200 times the sine of 49.1227. $907.3360, the j direction. And right here, guys, we have our coordinates for the B point. All right. Now, what was needed for me to solve this exercise? Of course, I've been explaining some different things along the exercise, but one that I didn't mention is that for when you have, for example, a summatory of vectors, for example, these 4, all you have to do is to create a resultant shape. The only inquiry that has to be met is that the tail must be touching the head. The tail, the head, the tail with the head. Alright? And this solution is going to be the resultant vector between the corner vectors. The only difference is that that vector is going to be created the other way around. Tail with tail, head with head. I don't really care about the other. For example, I could have created the solution like this. And the resultant vector is going to be the same. Alright? That is why the summatory between these two is this one. This is what the exercise is given to me. Now, besides that, I think that everything I explained everything. What else could be important? The cosine's law is important for you to have it in mind. This is pretty simple. One of the cathedus square is going to be equal to the summatory of the other two squared as well, minus 2 times, once again, the other two cathedus, multiplied by the cosine of the opposite angle. Right? The opposite angle of this cathedus is this one. The opposite angle of this cathedus is this one. And likewise, right here. I think that that's everything. That's how I learned the cosine's law. It is important for you to have in mind as well the sine's law, which is actually easier, but when you don't have any of the angles, it is easier for you to use the cosine law. if you have all the three catheters. And that's it, guys. This is how you can solve this exercise. Okay, I'm sorry, I was forgetting something. This is telling me that he wants to determine the location of a point B so that RAB is equal to 400 meters. But what happens if I, for example, do not use these 400 but these 400? This actually is as well a 400. Now, we could have created this other triangle and solve it. We are meeting the requirement, right? 400, and this is as well 1200, correct? Now, this exercise has two solutions. The one that we actually did and this other. And both of them are perfectly fine. Now, I'm not going to do it because it is the same process. And it is easier for me to do it just subtracting or adding this angle. Remember? Because right here we have this and this, but this angle is going to be the same one. Now, theta is right here, but it could be right here as well. So theta and theta. Alright, guys? Just to analyzing completely this exercise. And that's how, guys, you can solve this exercise.